Ever wondered how glass bottles, fiber optics, or solar panels come to life? In today's video, we'll take you behind the scenes to explore the fascinating process of how everyday materials like glass bottles, fiber optics, and solar panels are made. From the moment raw materials are sourced to the final product you see in stores, each step in the production of these items involves intricate science and advanced technology. Whether it's the delicate shaping of glass, the precision required for fiber optic cables, or the sustainable energy potential of solar panels, we'll uncover the amazing craftsmanship and innovation that goes into making these essential products. Before we start our video, don't forget to like, subscribe, and hit the bell icon for more insights. Glass bottles. Whether they're colored or clear, glass bottles and jars are among the most eco-friendly packaging solutions. Unlike paper, no trees are sacrificed in their production. Glass is crafted from abundant natural ingredients such as silica sand, soda ash, and limestone. Remarkably, glass can be endlessly recycled without losing quality. This makes it a sustainable choice, and its production process consumes significantly less energy compared to metals or plastics. The process of creating glass begins with the combination of three main ingredients. Silica sand makes up about 45% of the mixture and serves as the primary ingredient. Soda ash, comprising around 15%, helps to melt the silica uniformly. Limestone, making up about 10%, is added to strengthen the finished product. To further enhance the environmental benefits of the process, manufacturers also use recycled glass, known as cullet. The inclusion of a cullet not only reduces waste, but also lowers the energy needed for production, as a cullet melts at a lower temperature than raw materials. Some batches can have up to 90% cullet, which not only boosts sustainability, but also greatly reduces energy consumption. Once the raw materials are prepared, they are fed into a furnace where the temperature is ramped up to an intense 2,730 degrees Fahrenheit or 1,500 degrees Celsius. At this temperature, the mixture transforms into molten glass, which has a consistency similar to honey. This molten glass is then portioned into cylindrical gobs, each containing exactly the right amount for a single bottle. The gobs are carefully directed into molds where compressed air is used to shape them into the final form. Depending on the type of bottle being created, like a beer bottle, the molten glass may be tinted with iron, sulfur, and carbon to achieve a rich amber color. After the shaping process, the bottles are gradually cooled in a controlled manner to prevent thermal shock, which could cause them to crack or shatter. As they cool, they are coated with a lubricant to ensure smooth handling during the manufacturing process. Finally, the bottles undergo a thorough inspection for imperfections, ensuring only high-quality products are ready for distribution. The use of recycled glass and the relatively low energy consumption of the production process showcase glass's environmental benefits. From its creation to its endless recyclability, glass remains a prime example of sustainable manufacturing. Fiber optics. Fiber optics are the backbone of modern communication, enabling the fast transmission of voice, data, and video across the globe. These incredible systems use pulses of light, traveling through ultra-thin glass fibers to transmit information. The process of creating fiber optics begins with large glass tubes, which are carefully cleaned in a corrosive bath to remove any residual impurities. Once the tubes are thoroughly cleaned, they are fused into longer tubes by heating them to an intense 3,000 degrees Fahrenheit. A chemical reaction occurs within the heated tubes, causing soot to deposit along the inner walls. This soot layer then fuses into glass, forming the core of the optical fiber. The next step involves collapsing the tube under heat to create a solid rod known as a preform. This preform is critical as it serves as the base for the fiber optic cable. Once the preform is prepared, it is placed in a specialized drawing tower where it is heated to an even higher temperature of 3,600 degrees Fahrenheit. In this tower, the preform is drawn into ultra-thin fibers. These fibers, which are just 0.005 inches thick, are carefully monitored during the drawing process to ensure consistency and precision. To protect the delicate fibers from contaminants and environmental damage, the drawn fibers are coated with a layer of acrylic. This protective coating ensures the fibers remain intact and functional throughout their journey. Fiber optic cables are incredibly efficient, offering far superior performance compared to traditional copper cables. They carry more data, suffer from minimal signal loss over long distances, and are immune to electromagnetic interference, making them ideal for modern communication networks. Fiber optics have transformed connectivity by offering faster, more reliable, and higher capacity data transmission. From internet browsing to phone calls, fiber optic technology plays a crucial role in supporting our digital lives, offering a level of efficiency that copper cables cannot match. Car recycling. Every year, millions of cars are manufactured in North America, and when their life cycle comes to an end, many of these vehicles are recycled, giving their components new life. Recycling plays an important role in extracting valuable materials from old cars and appliances, with a variety of metals being salvaged for reuse. The metal waste generated from vehicles is divided into two main categories: ferrous metals, such as steel and iron, and non-ferrous metals, including aluminum, copper, and brass. Once cars and other scrap appliances are brought to recycling facilities, large machines such as cranes and bulldozers are used to sort and separate the materials. During the sorting process, items that cannot be processed, such as propane tanks and heavy iron, are removed to ensure safety. The remaining scrap is then fed into massive shredders via conveyor belts, where the input is carefully regulated by weight to ensure the right mix of materials. Inside the shredders, giant hammers break down the materials into smaller pieces, roughly the size of a fist. This process is essential for separating the components, and once the materials are shredded, industrial vacuums come into play to separate non-metallic elements such as rubber and glass from the steel. Ferrous metals like iron and steel are attracted to large magnetic drums, which efficiently pull these metals out of the shredded mass. Non-ferrous metals are treated separately. An eddy current separator is used to isolate metals like copper and brass from the rest of the materials. This device uses a rotating magnetic field to repel non-ferrous metals, directing them into designated bins where they can be further processed. The ferrous metals, primarily steel, are sent to mills, while non-ferrous metals are directed to foundries, where they are melted down and reformed for new uses. After the primary sorting process, any remaining waste is carefully inspected to remove any unwanted materials. Once all of the valuable metals, like aluminum, brass, and steel, are extracted, they are sent for further processing and reuse in manufacturing. This modern recycling process highlights the efficiency and importance of reclaiming valuable materials from old cars and appliances, helping reduce the environmental impact while supporting the demand for recycled metals in new products. Recycling not only conserves natural resources but also reduces the need for mining raw materials, demonstrating how efficient and sustainable the modern recycling industry has become. Solar panels. Once a concept confined to science fiction, solar energy has emerged as a practical and vital non-polluting energy source. Solar panels, built with photovoltaic cells, convert sunlight into electricity. These cells are made of crystalline silicon, with grooves functioning as conductors. Each cell module glistens with silicon crystals and must undergo meticulous assembly before becoming part of a functioning solar panel. The process begins by connecting multiple modules. Soldering flux is applied, followed by heating with an iron to connect the modules. Once soldered, the modules are cleaned using ultrasonic waves in water heated to 140 degrees Fahrenheit, ensuring perfect cleanliness before assembly. The modules are then grouped into sets of 4 with 9 modules per group, making a total of 36 modules soldered in series. Handling the delicate modules requires care. Technicians use a voltmeter to verify the voltage of each module, ensuring proper connections. Any faulty soldering is corrected at this stage. The modules are then positioned carefully with suction grips, and metallic strips are inserted to connect groups of modules. Next, a transparent, rigid sheet of layered glass is added to support the modules, forming a laminate that increases the panel's rigidity and durability. The nearly finished panel undergoes a sealing process to protect the modules. It is then placed in a vacuum-sealed oven where it is heated to 176 degrees Fahrenheit for 15 minutes. This process bonds all components securely together. Once out of the oven, the panel is tested in a solar simulator. The simulator mimics sunlight, and a voltmeter measures the electrical output to ensure the panel functions as intended. Another type of solar panel, made of amorphous silicon, is assembled differently. Its components, sourced from Europe and Asia, are mounted onto a plastic frame and glued into place. The frame is tightened with screws for stability. Regardless of the type, producing a single solar panel requires about an hour, with this particular facility creating 6 panels daily. Hydroponic lettuce farming. Hydroponic farming eliminates the need for soil, relying instead on nutrient-enriched water. This innovative method, known as deep pool floating raft technology, begins in the germination area. Seeds are planted using a steel tray with 276 holes. A vacuum hose ensures one seed is deposited in each hole. The tray is flipped over onto a foam block called an oasis, which holds the seeds in place. These seeds are coated in clay to retain moisture while allowing them to sprout easily. The seeds are watered during their transfer to a greenhouse where they float in a 12-inch deep pool of water. Technicians monitor and adjust the water's oxygen and fertilizer levels continuously. Unlike traditional farming, hydroponic systems recycle water, only replacing what plants absorb or evaporate. By the 4th day, sprouting is visible and the seedlings are watered and fertilized. Around the 7th day in summer, or the 11th day in winter, the first leaves emerge, prompting the first transplant. Workers transfer the lettuce from the 276 seed tray to a styrofoam board holding 288 plants. By the 13th day in summer, 20th day in winter, the plants are transplanted again to a less crowded styrofoam board with 72 spaces, providing more room and light. The final transplant occurs on the 26th day in summer, 45th in winter, moving the lettuce to a board with just 18 spaces. This gives the plants ample space to develop long roots, which are essential for absorbing water and nutrients. The lettuce is then moved to the production zone for final growth. Automatic machines transport the boards in this phase, optimizing space and resources. Hydroponic systems yield 500 plants per square yard, 5 times the output of field-grown lettuce. The method is also safer as it doesn't require pesticides or fungicides, and fertilizers don't contaminate the environment. By the 45th day in summer, 75th in winter, the lettuce is ready for harvesting. Workers trim yellow leaves, either cut the roots or wrap them, and vacuum cool the lettuce to extend shelf life. Cellulose insulation. Cellulose insulation is an eco-friendly material made from recycled paper, free from harmful substances like asbestos, fiberglass, and formaldehyde. It emits no toxic gases and meets strict safety standards. For smolder resistance, a lit cigarette is placed in a sample, and after burning out, the sample is reweighed. The weight loss must not exceed 15%. The production begins with bulk recycled paper loaded onto a conveyor belt and fed into a primary mixer to separate clumps. A magnet removes any metal objects like staples. The paper is then shredded into 2-inch pieces and mixed with boric acid, which acts as a fire retardant and helps prevent pests, mold, and decay. The fiberized machine breaks the paper down further into tiny pieces, about 1/8 inch long, and adds more boric acid. The entire process takes 5 minutes. Before shipment, cellulose undergoes open flammability testing, ensuring it meets safety standards. Packaged as loose fill, it's sprayed under pressure into wall cavities for superior thermal performance, offering a higher R value and preventing air displacement. In conclusion, the production of glass bottles, fiber optics, solar panels, and other essential products highlights the remarkable combination of advanced technology and skilled craftsmanship. Each manufacturing process involves precise techniques that transform natural materials into useful and efficient products. The use of sustainable materials like silica sand and recycled glass for bottles, or the reduction of energy consumption in solar panel production, reflects a growing commitment to environmental responsibility. Rigorous testing ensures that each item performs optimally, whether it's a glass bottle that protects contents or fiber optics that revolutionize communication. Ultimately, these innovations not only improve our daily lives, but also contribute to a more sustainable and efficient future. The fusion of science, engineering, and eco-conscious practices paves the way for a better tomorrow, benefiting both individuals and the planet. Thank you for watching. Be sure to subscribe to our channel for more exclusive behind-the-scenes looks at how everyday products are created. From the latest innovations to the timeless processes, we bring you the fascinating journeys that turn raw materials into the products we use daily. Don't miss out on our future content. Hit the notification bell to stay updated on our latest videos. Stay tuned for more.